There are three other areas when we talk about formulas that might be important as a foundational base for K through 8 students. These involve more miscellaneous things like the Pythagorean theorem, finding the sum of interior angles in geometry, and slope. Most of us probably remember memorizing the Pythagorean theorem when we were in school. A squared plus b squared equals c squared. And we probably remember solving problems with this. But why does that formula work? Again, there are just some laws of mathematics in nature that we can use to solve problems. And this is one of those. If we take side A of a right triangle and we make a square out of it, and we find the area of that square, and we do the same thing with side B, we make a square out of it, and we find the area of that square, and if we add those two areas together, they are always going to equal the area of a square we would make with side C. It's just a mathematical law. And for students to understand that and prove it is something that will help them understand the formula and remember it. They will get at the why of this mathematical law in nature. Let's do an example. If side A was 3 inches and side B was 4 inches, then finding the area of side A as we make it into a square would be 3 times 3, or 9. The area of the square we would make from side B would be 4 times 4, or 16. So if we go back to our formula and we think about the area of this plus the area of this, a squared is 9, b squared is 16, that has to equal c squared. That means the area of the square made from side C is 25, which means that C itself would have to be 5, because 5 times 5 gives us 25. A squared plus b squared equals c squared. When students can see something squared as an actual square and not just a number, it's much easier for them to comprehend the meaning of the formula. Teaching students how to find the sum of all the interior angles of a polygon is kind of a fun activity. Before we do that, we want to make sure that they actually discover how many angles there are in a triangle or a quadrilateral. So we could have students take a big piece of paper and draw a triangle. And they can draw any kind of a triangle they want to. And after they draw the triangle, we have them cut it out, and we have them actually chop off the angles. And if we have them line those angles up on a straight line, what they're going to find is that angle 1 butted up against angle 2, butted up against angle 3, no matter what their triangle looked like, is always going to make a straight line. And a straight line is 180 degrees. So students can actually discover for themselves, like a mathematician, that all the angles in any triangle add up to 180 degrees. They can do the same thing with a quadrilateral. They can draw any four-sided figure any way they want, cut off all the angles, put the angles on a straight line, line them up, angle 1, angle 2, angle 3, and angle 4, and they will find that when they do that, the angles make a complete circle around the line. That means that the angles in any quadrilateral will add up to 360 degrees. Again, students can discover this by doing this. We can use that information to find the sum of interior angles in any polygon. So if we want to know what all of these angles add up to, we can use that information. We can add lines to our shape to divide it into different figures. So if I put a line there, I now have one four-sided figure, 1, 2, 3, 4, and I know that all the degrees in that figure add up to 360. I also have one here, 360. So I can use that information to know that there are 720 degrees in this polygon. I could also divide my shape into all triangles instead of four-sided figures. So let's say I made this line here just as I had before, but now I also add a line here and I add a line here. Now I have all triangles in my shape. 1, 2, 3, 4 triangles, and I know that each one of those triangles has 180 degrees in it. So I can take 180 degrees times 4, which will also give me 720 degrees. This is how the formula for finding the sum of interior angles works. Here's what it is. Sides minus 2 times 180 equals the sum of the angles. So what did we just discover? How many sides did my figure have? 1, 2, 3, 4, 5, 6. So 6 minus 2 is 4 times 180 degrees is 720. This formula just reflects a law of nature, and that law states that no matter how many sides a figure has, you can always construct 2 fewer triangles inside the figure than there are sides. It's just the way the laws of math work, which is pretty cool. By having students each construct a different polygon, and by having them find how many triangles there are in each one, you can collect this information on the board as a class, and students can actually discover that pattern. They can see 6 sides, 4 triangles, 8 sides, 6 triangles, 12 sides, 10 triangles, and they can discover this law of math, making them more like mathematicians. Slope is an idea that is not always taught in the elementary grades, but it usually is taught in the middle grades. And teaching the idea of slope to very young students is not a bad one. They can understand the concept of it without actually working directly with the numbers or with the formulas, which gives them a good background. So what is slope? If I have a couple of points on this line, let's say I have -3, -1, -3, -1, there's my point, and I have 4, -6. There are my 2 points. If I construct a line between those points, my line has a slope. It's tilting, and it's tilting a lot or tilting a little, and it's tilting down or it's tilting up, no matter what points I use. That's what slope is. It's a formula to help us see a line and how it's tilting without actually having to draw it, without actually having to have a graph in front of us. So the formula for slope is measuring 2 different things. It's measuring the left and right range of my line, and it's also measuring the height, the up and down tilt of my line. So if I take the 2 numbers that reflect the up and down part of my line, the y-axis, and I take y2 and y1 and I subtract them, that will give me the range of height. So for example, on my 2 points, I have a height of -1 on this point and -6 on this point. So y2, -6, take away y1, -1, is the top part of my formula. x2, 4, take away x1, -3, is the bottom of my formula. The top is giving me the difference, the range, up and down. The bottom is giving me the range side to side. And when I put one over the other, that's telling me the slope. So -6 minus -1 is -5. 4 minus -3 is 7. So my slope is -5/7. What does that slope tell me? Because it's negative, it tells me that my line is going down instead of climbing up. It also tells me that my slope is not terribly steep. So when I work with slope and I see a lot of slope numbers, I can look at this number and I can almost picture what the line looks like without even having to draw it on a graph. I can also use this line to find other points on the graph. This kind of information is used often in the real world, and when slope is taught to students, I think it isn't always related to real-life things, and that's something we should do. But the idea of a slope of a line, whether it's going down or up, whether it's tilting a lot or a little, those are concepts that can be taught to elementary students, and then they can build on those concepts as they get into more advanced math.